All right, let's continue with part B, and we're gonna sort of like mimic the same process towards part B, but this time to evaluate y prime, we can just use the chain rule because the given function is e to the sine hyperbolic x, so e to the u. So you can go back to the derivative formula card and retrieve that the derivative of e to the u is e to the u times u prime. Okay, please sort of like convince yourself that this e to the u comes with the derivative e to the u prime, and that's exactly what I'm going to do here. Okay, so y equals e to the sine hyperbolic x, where u is sine hyperbolic x. Okay, all I need the derivative of sine hyperbolic x. And for this, you can use the derivatives and integrals of hyperbolic functions table. Okay, so sine hyperbolic u comes with the derivative of cosine hyperbolic u prime. There we go. So I'm going to go back here and write the derivative of that as cosine hyperbolic x. Okay, because here there is no function of x, but just x. Something like all I'm trying to say is like this is just x, and when it's x, u becomes x, right? In that formula that I just showed you in the table. So it's cosine hyperbolic x when you take the derivative of that. All right, so y prime is equal to the same exponential times u prime cosine hyperbolic x. Okay. So once you have y prime, then you know the slope of the tangent line at any point, but in particular, we are given the point 0, 1. And these are the x and y coordinates here. So I need the slope at x equals 0. And what is it? That is me plugging in 0 for x, okay? Okay, go ahead and use your calculator to check, to just calculate this. Sine hyperbolic 0 is 0, e to the 0 is 1, and cosine hyperbolic 0 is 1. So you should probably get 1 in the output of your calculator once you punch everything in, okay? So now I can go ahead and write down the equation of the tangent line because I know the point, which is 0, 1, and I know the slope. So here we go. Y minus the y coordinate is equal to the slope times x minus the x coordinate of the point. That is 0, right? Simplifying this, y equals x plus 1. Okay, so y equals x plus 1 is the equation of the tangent line. So let's say like you're in the exam, how would you verify or how would you convince yourself that this is the right answer? Well, you can graph these two functions, right? You can graph y equals e to the sine hyperbolic x together with y equals x plus 1, right? You can plot them both, and you get exactly this. Hopefully, you get exactly this after you plot. And you should probably put your x min, I don't know, negative 0.5, x max to be 0.5, or minus 1, whichever. But you should be able to see that this red line is sort of like tangent to the graph at x equals 0. So this is x equals 0. Okay. And this is the point, in fact, 0, 1, and we can perfectly see that this line is tangent to the graph at this point. Okay. All right. So that takes care of part B, and I think we're completely done with both parts of this question. Going back to that, there we go. And that's the end of it. Thanks for watching. I'll see you in another video. Bye.